You can click record that other thing. All right, let's see if it works now. And I'm not touching nothing. I'm not touching nothing. Okay, so 122. All right, so this one's our compound. Okay, 3 times 12 is 36. 3, 4, 5, 6, 7, that's 43. Okay, what do we add for the bromine? 79 and 81. So one molecule may have 79. That's how you get 122. One molecule may have 81. That's how you get 124. It's actually seeing the individual molecules with the individual isotopes. We're not doing an average, weighted average like they do up here, okay, on the table. So you got to remember that we're using whole numbers throughout this whole process. Okay, so if I lose this, what's left? Okay, this is breaking off. What am I going to have? 43. Notice that 43 is my what peak? What is the tallest peak called? Base peak. Okay? You were what?
It was on the old.
It was. Okay. All right, so let's look at the next one. Try. Oh, look at there. There it is. Okay. So look. It may not get recorded today. You think it's still recording? Oh, yeah, it is. All right, let's try that. That's kind of wild. All right, so what do you think the heteroatom is in this one? Iodine, nitrogen, bromine, chlorine, or Chewbacca? He's furry. He's not a heteroatom.
Oh, wait. It's not open.
I'm not opening it. I'm asking you. Chlorine. Okay, what made you pick that? Because this is a third of this. Okay, now I'm going to ask you to come up with the formula. Oh my gosh. What do you think? How would I do that? All right, well, what are my mass numbers up there, y'all? No, the molecular ion, the main mass numbers are 78 and 80, right? Those are because of the 2 isotopes of chlorine. Okay? What one is the 78 one, the more common one? What number? 35. So I'm going to subtract 35 off this because I already know I've got chlorine in my formula. Okay? So that leaves me with 43. Which is what? Well, just give me a formula. C. How many carbons and how many hydrogens? How many carbons? 3. How many hydrogens? See how we got that?
So what's the 63 and 65?
What are the 63 and 65? Any ideas? What's 78 minus 65?
Good job. Quick math.
13, right? So you lost a carbon and a hydrogen from your mouth. Okay. Notice that you still have bromine in, or sorry, chlorine in there. How do you know you still have chlorine in there? Because you still have the 3-to-1 ratio. Until you finally lose chlorine from your molecule and get to 43, okay, you are always going to have that little ratio because the heteroatom is still in the mouth. Okay, so let's see what, okay, I thought that might be next, but then I was scared. Okay. I know, I was scared to click it. Okay, so do you see it's isopropyl chloride?
Can we still
No. We'll get more chances. Okay.
So if you were asking this question on the test of, what's the,
Heteroatom in the molecule, you wouldn't have that. You would just have the spectrum and you have to figure it out.
wanted us to write down, do you want to write it like that or like that up there? Like
This is-
C3H7.
This is the formula, that is the structure. So that's the difference.
What would you ask for the
If I ask for the structure, I'm going to give you something else. Like I'd probably give you an NMR with. Because don't you think that, okay, you look at C3H7Cl, how many possible structures are for C3H7Cl? How many possible structures? There's just two, right? This one. And this one. Because there's only 3 carbons, okay? If you get to 4 carbons and 5 carbons, it gets bigger, okay? Do you think you could tell those two apart on the proton NMR? What would the top one look like in the NMR? What would you have? This would be a, what splitting?
Triplet.
Triplet. This would be a, this would be a, which would be farthest downfield?
Closer to 40.
The one closer to 40. Okay, now look at this one. Okay, what would the splitting of this be? What would the splitting of this be? What would the ratios be? This would be 6 to 1, right? Who would be farther downfield? The multiplet. Okay, so you see how without knowing the formula, but by using this to figure out the formula and looking at it in NMR, you can figure out what you're saying. Okay, does that make sense? Okay, so the first thing to do is figure this part out. Okay, who thought maybe there was a benzene in it? Is there a benzene in it? Why not? Because the numbers aren't high. Okay, so without even looking at the NMR, how do you know it's not this? Because 6 carbons adds up to what? 72. Okay, so be logical when you're figuring out your formulas. Your formulas have to make sense. Okay, first decide if there's a heteroatom, and then go from there. That's usually the easiest way. Okay? All right, let's see what the next slide is. Maybe. Oh. Okay, this shows you the 2 chlorines coming off, okay? And that's why the isopropyl cation is your base phase, because it's secondary, so it's the most stable that you can get with this. Okay, these are your 63 and 65 where they lost a carbon and a hydrogen. Okay. I'm not worried that you can do this. What I would want you to be able to do, if I said, tell me the structure for the base cake. Tell me why the molecular ion and the N+2 peaks look like that. That's the kind of thing that I'm worried about, okay? Because you can spend an entire class on nothing but mass spec, okay? All right, so this is an ether, okay? An ether has what heteroatom in it? Oxygen. Okay, has some issues a little bit there. Okay. Notice that our molecular ion for this compound is 116. Okay, now it's a little more complicated, right? 116 minus 15 is What's 116 minus 15? 101. Okay, here's 101. Okay, it's a pretty decent sized peak because you probably lose a methyl. You could lose a methyl off either side. Okay, you get the same weight. It's not going to say this is the same weight as this, but the structure's a little different. It doesn't detect it like that. It's going to put them together. So whether you lost a methyl over here or over here, it'll be the same weight. Okay, what do you think 43 is? What do you think the structure of 43 is? Remember, it has to be a cation. Okay. So what do you think 43 is? What do you think is the most logical? Yeah, do you think it's this piece right here?
Yeah.
Yeah. Okay. The secondary carbocation adds up to 43. What if it broke over here? What is this side? What does that add up to? 1, 2, 3, 4. 4 times 12 is 40. Okay, then what do we got to add? 9. What do we get? Is there a peak for 57? Yeah, it's not as big as the 43, but it's good stuff. Okay, now here are some of the what happens when it breaks. Because you have an oxygen there, it helps to stabilize and take on the carbocation. Okay, just like it does when it's doing mechanisms, and we use the O to stabilize the carbocation. Same kind of thing. Only this is just doing it in a vacuum. Okay, and so you can see 101, there were 2 possibilities, and 87 was that one up there, where they lost the ethyl, which is kind of wild. Okay, this is an alcohol. Thing about alcohols is they will lose water very readily. What's the weight of water? Of normal, old, boring water. What is it? 18, are you sure? Okay, so if you're trying to decide if something's an alcohol, first of all, personally, I'd go get an IR, but you know, sometimes you don't have that option on the test. So look for a loss of 18, okay? That'll help tell you if it's an alcohol. Okay, and again, the oxygen on the alcohol is going to stabilize stuff. Do I not have a spectroscope with this? On the next slide it is? Yeah, here we go. Okay, so look how little your base peak is, your molecular ion peak is, sorry. It's really little because it loses water so readily. Okay, so 102 minus 16 is 86. Did I do my math right? Is 86. Okay, so it's probably this 87 here. Okay. Now, if you lose the methyl, if you lose 15, oh, 15 is the 87. Yeah. If you lose the 15, the oxygen will stabilize it. And so that's the 87. Yeah. Okay, what do you think 45 is? Could you come up with the structure for 45? That wasn't on my last slide, was it? Is it on my next slide? Nope.
It is the CH.
Okay, so that would be so you're saying let's bust off this piece. This would be your carbocation, and it'll be stabilized by the O. Does that add up? We've got 24 plus 5 plus 16. What is that? 2, 3, 4, 45. Okay, you see what she did? She just busted off this piece right here and looked at what was left on the other side. You can bust off the methyl and you get what's left on the left, or you can bust off that butyl group and you get what's left on the right. The oxygen will help stabilize the carbocation. Yeah, typically. Like if you have a T-butyl on a molecule, you usually get a nice big peak for a T. Okay, which is, I think, 57. I don't know, I just threw that out of my brain from memory, so I don't know. Okay, so here is 3-methylbutanol. Notice that they're really nice, and they put a little arrow there that says M+, but you can't really see it. Now, one thing you can do, like I told you about last time, is you can change the positions in your mass spec to try to get it to show up. Okay, to try to get some. Do you have this one?
Is that a word?
It's out of order? All right, my bad, sorry. Okay, okie dokie. All right, let's look at, so don't worry about trying to figure out every individual piece. Just worry about the big piece and the molecular ion. That's really what you need to do. Okay, notice they show you down here how they ended up with an allylic carbocation. Well, yeah, that's fine, but I'm not going to help. Okay, ketones usually give you a nice big molecular ion peak, a decent size one anyway. Okay, so this is 2-pentanone. 2-pentanone will do a fancy rearrangement that's referred to as the McLeod. Okay, look what was lost from the molecule. I'm not worried about you knowing how it does it. Go back. Okay, you end up losing ethylene off the molecule, and your carbocation is actually an oxygen. Okay, that's where the cation part is, and in this one it weighs 58. So you get a nice big peak at 58. Do you have this one in your DEL? Okay, because it didn't come up on mine. I don't know. Okay, this is a carbocation that is benzylic. Benzylic and allylic, in particular benzylic, will give you big peaks on the mass spec. Okay, so what's a weight of the benzylic carbocation? Let's figure that out. Okay, so this is what we're looking at. Okay, so we've got 7 carbons, 7 times 12 is.
Yep.
Right? 84. Like, seriously, write it down. Okay. All right, now how many hydrogens? Yes, good. And that adds up to 91. Okay, 91 is a benzylic carbocation. Now what happens in the NMR is that when that benzylic carbocation gets formed, it rearranges. Do I not have that little picture? Oh, to form a 7-membered ring cations called tropylium ions. Surely I have that picture. There we go. There's my tropylium ion. Do you see there's a big circle in the middle? Okay, we're going to talk about what that circle means. Okay, but because that tropylium ion is so amazingly stable, the molecule rearranges to that. That doesn't happen in solution chemistry. Your benzylic carbocation tends to stay the benzylic carbocation. This is occurring because we're at high temperatures in a vacuum, bombarding with electrons, and the molecule is falling apart. Okay, so that's how come you get it. But that's called a tropylium ion, and that's the other thing that is pretty commonly referred to. Like I said, you could do a whole class on that. Now what is this?
That's what we already did.
We already saw that, didn't we?
Yeah, that was the order.
Yeah, it was that other one. Okay, how about this one? 2,6-dimethylheptane for all. Okay, so notice that when that what is the, let's see, what are the biggest peaks? Look, we got 2. So what do you think they are? The number is right under the one that stands for it, I think. All right, I'm scared to touch it, so. 41, 42, 43. So this one over here is 43, I think. Like you literally just count across. Okay. When you get it off of a mass spec, it typically will give you a printout with the picture that looks like that. And then underneath it will be a table of all of the little numbers. Okay. All right. So what do you think 43 is off of this? Look at your little structure up there. What do you think 43 would be? The isopropyl group. Okay. Probably the isopropyl group.
So when you
Okay.
have one that's 42, 43.
Probably you're starting to get some loss of extra hydrogen, and you're probably getting some isotopes in there a little bit, but pretty much it's going to be loss of an extra. Little hydrogens can fly off. They're kind of weird that way. Okay, that's why we're not going to worry about the structure of every single peak. So what do you think 126? You think 120? Do you think 126 is a molecular ion? How would you know? Well, you got the formula or the structure, right? So what's the formula? See what? Let's see if you can add this up. See what? How many? 126? How many? How many carbons? 9. Okay. How many hydrogens?
Yep.
How many? 20.
Yeah.
Okay. Anything else? There's a what?
No.
An O. Okay. So 12 times 9 is 108. So we got 108 from the carbons. We have 20 from the hydrogens. And what do we get from O? 16. I didn't even answer you. Everybody knows 16 is the most common isotope of oxygen, right?
Yep.
Okay, so this is going to be 2, 3, 4, 144. Wow, what's 126? We say about alcohol. What do they like to lose? Water. What's 144 minus 18?
126.
126. Okay. Okie dokie. How would we get a peak at 111? What's 144 minus 111?
33.
33. Any brilliant ideas how we could lose 33 off of that? Let me draw my structure. Two carbons is 24. I know, that's why we only worry about the bigger. Because some of the little ones are weird. What's 87? 126 minus 87. 39. That better? I keep thinking one of them is going to be, you're going to lose this and it's going to be this side. Am I wrong? That's too many carbons though. 4 carbons is,
What if it's just like the OH with 2 carbons? Like,
see, if you got this, forget there's a hydrogen there.
yeah, then, but not that split. So like split it into the carbon to the left.
Over here.
Yeah,
Oh, and lose the isopropyl.
yeah.
Yeah. Yeah. The oxygen should stabilize though, so you should get somewhere. Maybe it's just too branched that it won't do that. I don't know. I'm not gonna worry about it. Okay, that's mass spec, that's all we're gonna do. Okay, I don't know if Jay-Z is gonna do any in lab with you or not. We do have several mass specs downstairs. Okay, all right, now I did post chapter 14. You're gonna see it's really short. So make sure you get 14 and 15 by next time. Okay, and I'll put 15 up today. Hey, are you gonna come talk to me? Oh, let's see. So how many